Hi there, everybody. Welcome to Enhancing Your Serverless Development Process with Thomas Boyder. I'm Laurel Bellman. I'm going to be helping out with the Q&A today. So if you are attending this session virtually, please put your questions in the chat and I'll read those out. If you're attending in person, please just stand on up, or if you would like to sit down, you can do that as well. Just speak loudly and we'll be able to hear your question. With that, I'll let Thomas take it away.
Okay. I wanted to first say thanks to Zakai for the cloud community stuff. It's good to know that when you start this AWS and cloud development journey, that you don't have to do it in a bubble. Cloud services has been super helpful. You have cloud services in the cloud community, so it's been super helpful for me over the years. To get started here. Let's see, we're covering my notes here. I'm going to be doing like a 10-minute talk here, so it's going to be going kind of quick. My name is Thomas Boyder, and I've been with UW for about 15 years in various IT roles, and I've been working with AWS for about 2 of them. It's not a long time in cloud years. I joined the Wisconsin State Lab of Hygiene in the fall of 2023 and worked with a team of 6 people in bioinformatics. We use a lot of AWS and Python, and Lambda is a big piece of it. Today I'm going to do a quick overview of the method I use to develop Lambda locally. It's helped my Lambda development workflow become more efficient, isolated, secure, consistent, and shareable. A quick overview of Lambda for those that aren't familiar with it. Lambda is referred to as serverless because you can just run code and you don't need to be concerned with provisioning or maintaining the systems that run it. Cost is based on execution time, the amount of storage in use, both disk and RAM, the amount of data transferred, and a cost for invocation of the code. AWS pricing isn't known for its simplicity, but often the resource is a free tier for a period of time, so you can determine if it's worth the spend to implement. When you first get started with AWS Lambda, you'll find yourself in this browser-based Lambda editor at some point. It's pretty limited. There's no Git or other version control, and I found myself using cut and paste as a workflow for making more than one-line revisions. Debugging is limited to print statements and CloudWatch, waiting for logs to populate and tell me about simple syntax errors. The whole process was slow and tedious and didn't scale well for large projects. I stopped mid-paste one day and wondered why this felt so much like banging rocks together. I spent a couple days looking around the internet for alternatives, but didn't find anything that felt like a complete fit. There were a lot of innovative ideas, but I didn't find anything but I wanted to use tools I was already familiar with. Some solutions seemed like they required more stuff than I needed, while others involved learning a lot of additional tech or partially solved one problem but created others. And I wanted something without a considerable learning curve that didn't include a lot of sharp edges to implement or share. After trying a few things that didn't pan out, I ran across the Microsoft Dev Containers extension. This extension enables VSCode to execute your application within a Dockerized environment rather than directly on the host system. I was intrigued because this meant I could have an isolated dev stack that did have a consistent baseline, and it was shareable, and modifications easily tracked through Git. Without using persistent storage, it's a much more ephemeral environment than a host system, so retrieval of any secrets or keys after the container is shut down reduces the risk of exposing those secrets. Especially for software like Git and AWS CLI, which utilize unencrypted configuration files in your home directory to store secrets. As it turns out, Boto 3, the AWS SDK for Python, works fine in this environment too. This means I can use the VS Code runtime debugger to inspect data and code execution on the fly while it's interacting with AWS or any resources I have provisioned there. I wanted to present a live demo for this talk, but the projector systems aren't set up for it, and it was recommended we don't connect personal devices to them, so I'm kind of work within those constraints. Besides that, any technical issues in a quick talk like this kind of sink it. So we'll have to settle for a screencast here in the next slide. So I'm going to try and pull that up. And we'll go to. So we'll take a quick look at the installed extensions that are needed for setting up this environment. Other languages may have extensions for this too, I'm not sure. Terraform isn't necessarily needed. I just had it installed to provision an AWS demo earlier in the day. To save some time, I pulled down my dev docker repo from GitHub, and I'll include a link at the end if anyone wants to try that. I'm exporting a variable to name the container before building it, and then running make to launch Docker in an interactive session with a volume mount. I use make files pretty heavily because commands to build out a project can be consolidated into a single file and checked into Git. Once that's running, we can attach VS Code to the Dockerized environment from the command palette menu or F1. Once attached, VS Code launches in a new window. Any code you run here will be running from the perspective of the container, so any software you install in the container is available to your code. I'll drop in the AWS credentials for the A Cloud Guru sandbox I provisioned earlier. Thank you, Zakai. But the sandbox has since expired, so I won't bother masking them. With the credentials in place, I like to test them by returning the account number I'm working with, or just list any S3 buckets that are in the account using AWS CLI. This is a nice way to catch any issues with the credentials and verify you're making changes in the right place. If everything looks good, we can go ahead and start up the runtime debugger by selecting it from the run menu. A debug console will open in the lower right that looks just like a regular terminal, but the debug console is where you can export variables needed for the Lambda routine, which would otherwise be provided in the provisioned AWS Lambda environment. This Lambda function will be looking for two environment variables named debug mode and S3 bucket name. Debug mode is what allows us to drop into the test stub and call the Lambda event handler locally. This is handy because it's not a standard Lambda environment variable. If you forget to remove the test stub, it won't get executed on AWS. Now with a breakpoint set, we can go ahead and start up the debugger and drop into the test stub since the debug environment is set up correctly. From there, I can step into the Lambda handler as if it was being executed right on AWS. The handler can make calls to the AWS API using the Boto3 module, like the list buckets function does right here. The return value from Boto3 is placed in the buckets variable. I can pause execution and inspect that variable along with other metadata returned from AWS, and also fix any syntax errors without needing to look at CloudWatch logs. You can add variables to the watch list, so you don't have to scroll through the pile at the top. This is really handy when working with other AWS services like Parameter Store Secrets Manager, where you probably don't want those things going into logs or printing output. Variables can easily be modified during runtime to test fixes, such as adding a prefix to a file name that's about to be written to an S3 bucket like I'm doing here. I'll step over a couple lines and modify the source file variable used by the put object API call. There's a lot of info in the variable section, so you can see how adding a watch would be quicker. Luckily, variables are in alphabetical order. So I'll go ahead and scroll down and add Lambda local dev to the source variable, and then leave the UTC timestamp as is for unique file name. Once that's set, we'll continue on with a put object API call to write our new file name to the S3 bucket. And if we go over to the sandbox console and refresh the bucket list, we can see our file was created by running our Lambda function locally. So that's about all I could fit into 10 minutes. If we have any time remaining for any questions, we can take those. And I'll see if I can get to my last slide here. Maybe. Whoops, where'd it go? Right there.
So are you running, what's running locally and what's running in the cloud? Docker locally, right? Are you running that against AWS Lambda in the cloud, or is that like a local thing?
The VS Code is running locally on my system, and because it's using Dev Containers, it runs, you fire up a container, Docker container, of course, we're all familiar with those, and VS Code will execute based on the file systems and libraries and operating system that's in that container. So you could your host system could be like Ubuntu 22.04, and you could have a container with Debian 10 and be running your dev container on that. So it's kind of handy. What's really cool about it is it's really handy if you have several developers who are have a stack and you want to standardize on things like Postgres and Ruby and Rails and all the stuff that goes with that. Stick it in the container, fire up dev containers, everybody's in there. If you volume mount your home directory, like in a place away from where you'll normally have modifications going in the container, you can use symlinks to your git config, so that when you're in the container and you do like a git pull or a git clone, it's got some idea of what user you are in git. And by making your home
the new sandwiches are great. Yeah.
Yeah. Yeah. So you can make those changes and have those files that you need for configuration right there. So.
Wow, that's awesome.
Yeah.
Other questions? We still have time for a few more questions. I haven't seen anything come into the chat yet.
All right.
Yes.
Roll the credits. Oh, wait.
So when you're ready to package, how are you then moving it from the local environment to the packaging? Yeah.
All right, so someone mentioned Terraform earlier. That is probably a big piece of cloud development. I mean, if you're going to do anything, learn Terraform. It's really a way, it solves so many problems. You can document your changes, you can check it into Git. You don't have to do like a screencast to, well, I click this and click this to spin up this EC2, and here's my security group and my ACLs. It just all goes into Terraform. So the console is great for experimenting and finding out things, and that's why the sandbox is so nice, because if you blow it up, who cares? But Terraform is really great. So we have all of our infrastructures code in Git. We pull down a repo. I pull it down in the dev container, and then I'll just run Terraform or Tofu or whatever, and TF apply, TF plan, and just boom, it's up there. So, and again, the sandbox is super nice for that, because at one time I was working with 4 different AWS accounts, and I was like, where do I test things? These are all being used by somebody for something, and I don't want to nuke a VPC and have something messed up. So mostly Terraform for deploying packaging.
Follow up then, are you doing a mono repo for the app and the Terraform that goes with it, or are you separating your Terraform?
Yeah, so we're using TFRs. Okay. So this is like a whole other talk, but you're right, you're on the right track. So we do have, we have our dev TFRs and prod TFRs that one of the developers from SNPH turned me on 2 years ago. Super awesome way to do it, because you can have one repo and different variables files to configure your dev and your prod and your test. And so yeah, it's great that way. So Terraform really helps a lot.
I will add one more thing, Tom. Thank you very much, Thomas. And I think that our cloud office hours, like usually like 5 or 6 of us, like with Mike and other people, and Thomas is there. We have like concerns that like really want to understand. I think we will have people like Thomas and like
Yeah, it's been super helpful for me having those resources there, because otherwise you get in this and you're like, what am I doing here? And I just spun up an EC2, and is it secure? I don't know. And somebody will be like, well, did you set up your security group? You can limit access by campus VPN subnets, and it's like, wow, it's a great idea. How do you do that? So.
All right, I think that's about all the time we have. Thank you so much, Thomas, for
You're welcome.
presenting. We had a great conversation about it. Please feel free to take a 10-minute break, and then we've got another presentation starting at 1:55 in both of these rooms. So thank you.